What is power, and how is power distinguished from energy? By definition, power is the rate at which work is done. We symbolize power with the letter P, and when we talk about calculating power, we're always talking about calculating the average power. And I'll explain why. Power is equal to work divided by time, and work, when we're doing work, we're talking about transforming energy, and when we're talking about power, it's the transformation of energy per unit time. Now, when we do work, the work isn't necessarily a constant rate of work. So that's why we say it's the average power. If the work goes up or down, but overall, the average work per unit time, that's what we're talking about when we talk about power. So again, the formula, the average power is equal to work divided by time. And as we know, work is measured in joules, and joules is also the unit of energy. And T is typically measured in seconds. That would be the MKS units. And that means that the power units would be joules divided by seconds. And 1 joule divided by second, we have a special name for it called the watt. So 1 joule per second is equal to 1 watt. Now, the idea of power was explored by a gentleman by the name of James Watt. He invented one of the first steam engines, and he was interested in finding a way of measuring power. And just to quickly tell you about the experiment that he performed, he measured the amount of work a horse could typically do in an 8-hour day. And so for that reason, we measure a lot of our machines, our car engines, in horsepowers. And by definition, 1 horsepower is equal to 746 watts. So I want to emphasize that power is not the same thing as energy. Something can be energetic, but its power is a measurement of something else. Let's look at an example of a person. The work output, how much work I can actually do, the work output of a person is limited by 2 things: the total energy required to do the work and the time to transform the energy. Remember, when you do work, you transform energy. And the energy required and the time to do that is joules per second, and of course we call that the power output. Now, the same person can transform a lot of energy for a short period of time, or they can transform a small amount of energy for a long period of time. And regardless, their power output would be the same. So let's have a look at some equation manipulation. We have the basic formula: average power is equal to work divided by time. That's our definition, the rate of work being done. Now, we know that work is force times distance, so we can rewrite the formula as power is equal to force times distance divided by time. If we separate the distance over time, we know distance over time is the same thing as velocity. So now what we've done is we've rearranged or transformed the basic formula in terms of force and average velocity. So this formula right here can be used to determine the power to move an object at constant speed, or to achieve that particular speed by accelerating from a low speed to a higher speed. Another thing that we can do with power is we can look at the power to raise an object. Well, the work that it takes to lift an object would be equal to force times distance, and if I'm lifting, the force would be the object's weight, or mg. So the power to lift an object would be mgh divided by the time it takes to accomplish that lift. Power is measured in watts, and if we look at these individual units here, we can figure out in terms of MKS units, what is a watt? Well, mass is measured in kilograms. Acceleration is meters per second squared, and height is measured in meters, and time is measured in seconds. And if we simplify this, we get kilogram meters squared divided by seconds cubed. And that is equal to 1 watt.